Assalamu alaikum students. Today is our next lecture, and that is we have done before how to solve the system of linear equations by direct methods, and today we will study how to solve the system of linear equations. So basically we have two iterative methods, that is Jacobi's. First method is known as Jacobi's method. The scientist or mathematician called Jacobi introduced this method, and this is an iterative method where initial approximation is assumed. We just initially approximate this solution and is modified towards the solution in an iterative way. Okay, so it is also, this method is also known as a method of simultaneous displacements. Okay, I will tell you the procedure how it is solved, but before that I will tell you what is the condition for convergence of this method. So this method is applied only if we have AII mod is always greater than the sum of all the entries in a specific row or in a specific column, where I starts from 1 to n and I should not be equal to j. So the simple thing is that the diagonal element within the row we check it is always greater than the sum of all the rest of the elements in a row or in a and also in a column. So a11 should be greater than a12 plus a13. a11 should be greater than a21 plus a31. Similarly, a21 should be greater than a12 plus a22 should be greater than a12, and a32 plus a32, and also a22 should be greater than, I will tell you in the specific matrix. So the diagonal element should always be greater than the rest or sum of the rest of the entries in a specific row and in a specific column. So let's start with the example. So we have this example number 1, and that is 9x plus y plus z equals to 10, 2x plus 10y plus z equals to 19, and 3x plus 4y plus 11z equals to 0. So first is to check that whether this method is applied or not. So the coefficient matrix is 9, 1, 1, 2, 10, 1, and 3, 4, 11. So within the row we can say that 9 is greater than 1 plus 1, 2, and within the column we say that 9 is greater than 2 plus 3 is 5. Yes, this is true. So for this is a11, a22. So 10 within a row we can say 10 is greater than 3, 2 plus 1, and within the column we can say that 10 is greater than 5. It is true. So for this a33, 11 within a column we can say that 11 is greater than 2, and within the row 11 is greater than 7. Now we can apply the Jacobi's method here. So we start our method. So first of all we assume its initial approximation. Initial approximation is, if you every time initial approximation is given, if it is not given, then you assume that let x, y, z, if I write this column vector in a transpose, be 0, 0, 0. So this value is for x, this value is for y, and this value is for z. So let's start. And first step is, before that I have to tell you that you have to write the first equation in terms of first variable, and second equation in terms of second variable, and third equation in terms of third variable. So first equation is you have to write it in terms of x. So x equals to 10 minus y minus z divided by 9. This is first equation. And the second equation you have to write in terms of y. So y is equal to 19 minus 2x minus z divided by 10. This is second one. And the third one is 0 minus 3x minus 4y divided by 11. So this is third equation. Okay, so I guess that you have to start with this initial approximation. So if I replace the value of y and z, you get the value, modified value of x. So if we use these values, 10 minus 0 divided by 9, so 10 by 9, that is 1.111. If the tolerance is 4 decimal places, then you can write this value as 1.111. so x to the power 1 means this first iteration. And also for first iteration you have to find for this, so 19 minus 2 into 0 minus 0 divided by 10, so 19 divided by 10 is 1.9. and also z to the power 1, first iteration basically, 3 into 0 minus 4 into 0 divided by 11, so that is 0. So it means that now your values are modified. This is the value of x, this is the value of y, and this is the value of z. So 1.111, sorry, 4 times 1, because tolerance is 4, and 1.9 and 0. So now we start with our second iteration, and x to the power 2 is equal to, now the equation remains same and just the values are updated. So 10 minus y is 1.9 minus z divided by 9. So the value will be 1.6778, and similarly y to the power 2, that makes it 19 minus 2 into x is 1.111, and minus z is 0 divided by 10. So if we solve it, you get the value is minus 0.9939, and if it is z to the power 2, to get this value 1.111 minus 4 into y is 1.9 divided by 11, so you get the value, and that is sorry, this value is 10 minus 1.9 is 0.9, and I just replace these values, 1.6778, and this value is minus 0.9939. Now your second iteration has the modified values of x, y, z, and 0.999, 1.6778, and minus 0.9939. Okay, now in the next step, you have, in the third iteration, you have to replace these values in the equation, and that is x to the power 3 is equal to, that is third iteration basically. So 10 minus y now is 1.6778, minus z is minus 0.9939 divided by 9. So x to the x3 is, okay, x3 is 2.0 it's 1.03, sorry, 1.0351, and y3, if you repeat these all values, so 19 minus 2 into 0.9 minus z is minus 0.9939, so you get the value, and that value is 2.0182, and z3 is, by solving it, minus 3 into 0.9 minus 4 into 1.6778, and that is minus 0.8556. So your next modified iteration, you have to take x is 1.0351, y is 2.0182, and z3 is 0.8556. So you continue this process. You can take it, you can write it in the form of table, and you continue this process until the values of, within 2 consecutive iterations, the value of x, y, z starts to appear repeating itself within that tolerance. So up to 4 decimal places, your solutions, XYZ solution set should be accurate with, or precise with each other. So this is Jacobi's method. So this will, I guess this complete question will solve within 13th iteration. Within 13 iterations you get the solution and group starts to repeat itself. Okay, so this is a Jacobi's method. Now we come to the Gauss Seidel method. That is also another iterative way to solve this equation. So I use this Gauss Seidel method. I try to solve this same example with the Gauss Seidel method. So what is a Gauss Seidel method? Gauss Seidel method, the concept of this is that you use the most updated modified value of x and y and z. In Jacobi's method, you fix those values x, y, z within an iteration, but Gauss Seidel method uses the most modified recent calculated value of x in y and the recent calculated value of x and y in z. So let me do this question in that way and you will get the solution. This method is also, Jacobi's method is known as simultaneous method of simultaneous displacement, but this method is also known as method of successive displacement. So because your values are modified in a very efficient way. So I start this with this initial approximation for first is 0, 0, 0 and x is, for example, 10 minus 0 minus 0 divided by 9 and that will be 10 by 9 and y is equal, first iteration remains same, 19 minus 2 into, no, it is not same, in the y you can see the difference. So 19 minus 2, now you don't use the value of x0, now your value of x is modified, so 1.111, so you use this value 1.111 minus, now z is not modified right now, so divided by 10. Now your value will be 19 minus 2.222 divided by 10. Your value now is 1.6778. It remains same. Okay, z has now the values of modified x and y, and that is 1.111 and 4.16. You don't use y as 0. It is 1.6778 divided by 11. So what will be its value? Minus 3 will be modified as minus 0.9131. Okay. Oh, now in the second, so this is the first iteration, and for second iteration you can use this pattern. X to the power 2 is, use this modified values of y and z. So 10 minus 1.6778 minus plus 0.9131 divided by 9. So what will be the value? Let me calculate this. So it converges fastly toward the solution. Minus 1.6778 plus 0.9131 divided by 9. Okay, so x1 will be 1. So second iteration x is 1.0261. Okay, so for y we take the value of this modified x, and that is 19 minus 2 into 1.0261 minus z is not modified yet, so you use this value divided by 10. So if you use this value, then you will get the solution. So you get the idea, and I guess this if it is solved within the 13 iterations in the Jacobi's method, and if I solve it with the Gauss Seidel method, then it will require only 4 to 5 iterations to solve. So technically Gauss Seidel method is more faster converging method than the Jacobi's method. So this is all about those two iterative ways, and we will do its MATLAB program. And I hope that you understand. If you have any queries, you can ask me in the online lecture. Thank you so much.